Logistic Growth by Pedro Delgado, Lucia Hernandez, and Samantha Ortega. P.F. Verhulst was the man who founded the Standard Model of Population Growth. He was able to predict the U.S. population of 1940 using the first 5 U.S. census in 1840 and was only off by 1%. In real life, we can use this model to conduct scientific studies researching microorganisms like plankton. But we don't like plankton, so we're just going to say bacteria growth. Just as Verholtz did, we can use the logistic growth to predict U.S. population through census that are done every 10 years. Lastly, the most common real-life application is the wildlife populations for creatures like fish and chupacabras. There are 4 equations you need to know. The growth rate, which is dp over dt, equals kp times L minus p, or it can be rewritten as dp over dt equals kpl times 1 minus p over L. Next is the population equation, p of t equal to L all over 1 plus ae to the negative klt, where a is equal to L minus p sub 0 over p sub 0. Important things you need to know is that L over 2 is a max growth rate. As the limit approaches infinity, the population will equal your carrying capacity L. For variables, K is a constant of variation, L is a carrying capacity, and P is a population. Now, if we don't have a population at all, there is no way you can have any growth rate. A standard logistic growth graph looks like this, where the carrying capacity is a horizontal asymptote at L, the y-axis is the population, and the x-axis is of course time. Our first example is from 1998 BC multiple choice number 26. The population P of t of a species satisfies the logistical differential equation dp over dt is equal to p times 2 minus p over 5,000, where the initial population p of 0 equals 3,000 and t is time in years. What is the limit as t approaches infinity? First thing we do is we see what we're looking for, which is carrying capacity of the population. Then we see that we can manipulate the given equation to get L by factoring 2, which allows us to see that L is equal to 10,000.